Welcome to part 1 of Competency 3. In this video, we will apply number theories. Before we begin, we need to discuss number theory. The first 4 elements are the additive identity, the multiplicative identity, the additive inverse, and the multiplicative inverse. If you're not familiar with these particular items, I recommend that you become familiar. There are a lot of great videos out on the internet that would be extremely helpful. At the end of my videos, there's one particular set of videos on YouTube that I'm very fond of that I think are nice. But it's up to you. There are so many good people out there. All right. So if you have to, stop the video, pause it or stop it, and write down these elements or look at them so you can go find a good source. All right, let's move on to the next set. Okay, the next set of items are reflexive, symmetric, transitive, and closure. These ideas are kind of a modern algebra concept, modern algebraic if you took these courses in college. Okay, but they're not difficult to understand. Reflexive is just, A equals A. I know that it seems like a very simple concept, but it can become very complex and complex to prove. Okay, but we don't have to do that. We just need to know that all of these things exist. Like symmetric, we understand when things are symmetric. If one item equals another, then what it equals the one that we began with. Okay, and so just take a look at that. Transitive is a way from there's like a connective. In this situation, B is your connective. So that gives you A is equal to B. Okay, closure, now that's a little different. With closure, this definition is very vague. What closure means, let's say, if you start out with fractions and you only have fractions with whole numbers, let's say fractions with whole numbers, and let's say positive, not even negative. So you have all the fractions that are positive with whole numbers, okay? Like 1/4, 1/5, and so on, or 2/3. All of these. If you apply an operation, you have to end up the value, the resulting value, the answer must also be the same kind of fraction. If it's anything else, then you don't have closure, okay? And it's an invalid operation on those items that were given. So that goes in depth. How far you get depends on the type of question and the situation. Okay, let's move on to the third set of number theory items that we need to discuss. This is a little bit more about closure, a little more detail. So let's look. It says given a set of real numbers are, okay, we're talking about all the real numbers. So if we have A times B and we multiply them and they're still in the real numbers, that will satisfy closure. Because I started with a real number and I'm still in the real numbers. So all's well, and I can say that I have closure and it's satisfied, whatever the conditions are. Okay. So then if I have two real numbers and I add them, and after adding them, they are in the real numbers still, I come out with a real number for all of the A's and B's, whatever they are, whatever, I'm given, and I still come out in the real numbers, okay, then I still have closure and I'm fine. But let's look at this last situation. It says given a set of integers, and then they say z, because z stands for the integers, we have x times x to the -1 equals x over y, but that's not in the integers. So what they're saying, if you take x, it's a whole number, given as x, it's an integer. It can be negative, it can be positive, but it's a whole number. And I multiply it times 1 over y, which is a fraction. When I multiply those, I no longer have an integer. I have a fraction, which is a real number, but it isn't an integer. It's just a form of real number. And this will not satisfy closure. So this is a situation that you really have to think about and how that works. And of course, it all depends on the question that you're asked in the first place as to what your closure is. If they ask for decimal and they say it has to be a decimal, but when you did calculations, you didn't get a decimal. So you're not satisfying the question or the closures. So either the question is going to be false or your calculations are wrong, one or the other. All right. Okay, now let's go to some actual questions. Number 1, which expression has a value of 15.4? Well, in this case, we can just simply use our calculator. The first thing I would recommend is to put in 15.4 as is, and then take a look at what you might come up with, okay? All right, so let's say 15.4, enter it in. First you type it in, then you have to enter it. Okay, let's push the toggle. 77 over 5, okay? So we know the decimal, we know the fraction, all right? So now let's look at our choices and see what we can come up with. Of course, A, B, C, and D, simply type them in as is, okay? Even though some of it you might see you could do it, by hand or in your head, I don't recommend that, all right? So let's give it a try. Let's go with A, okay? We have, that's 5.4 parentheses. Now, for that mixed number, I use second fraction, sets us up, and that's 3 arrow over 2/3, 2 over 3. And I like to go all the way out and close my parentheses. You don't necessarily have to. Okay, let's push enter. And I would say not. Okay, let's try B. Okay, here, let me mark that one out as we go through them. A is a no-go. All right, now, 54.12. And we're going to divide it by fraction 1 over 3. And double check, make sure I put it in correctly. Push enter, even push toggle. Well, of course, it's not equivalent. Okay, you could kind of see that even if you just divided everything by 3, it's simply not going to work. Okay. All right. So actually what happens is you're not just dividing by 3, you're multiplying by 3 because of the rules of the operation. You have to multiply and then use the reciprocal of 1/3, which is 3. So that's not going to work. Now, that's kind of what's going on with the next one. You're really multiplying everything by 4. Okay. Well, let's put in the calculator regardless. 3.85, right, divide 0.25. I'm typing it in exactly the way I see it. And there you go. That one is valid. So I'm going to say C for now, but let's put D in just for some fun. But if you look at it, you can tell D's not going to work because 30 times 2 is 60. So obviously this is going to be over 60. Let's put it in anyway. So 30.8 parentheses, 2.5, close parentheses, enter, 77. I had a feeling it would be a whole number. Okay, let's look at number 2. And again, we have the convenience of our calculator per se. So just type it in the way you see it. Okay, so I'm going to go ahead and clear those out. And let me clear everything because this is going to take up some space. All right, so 2, and you want carried up, -1, but you will have to arrow all the way over. And now that is divided by the fraction 1 over 4. Okay, take a look. I've entered it correctly. I've got everything. Enter. It's 2. Okay. Now let's look at number 3. All right. It says, what is the value of the expression? Okay, same thing as above. They're all the same, looks like. What's the value? Right? Type it in like you see it, just as before. So 3, caret up, -1, arrow over, parentheses, fraction, 1 over 3, arrow over, push enter, 1/9. Ugh, but we don't have that option. Don't stop there and think you did something wrong. Always push the toggle to check it out. And we do have the correct value. That would be option C. All right, move this up just a bit. Okay, oops. All right, that didn't help much there. All right, which expression can be used to find the value of 3/2 divided by 1/8? Okay, just put it in just as before. Okay, fraction 3 over 2, arrow over, division, fraction 1 over 8. All right, and I've got the correct numbers. Push enter. It's 12. Okay, all right, let's try number 5. Number 5. The temperature outside is recorded for 6 hours. The temperature dropped 3 degrees each hour for the first 5 hours, and then rose by 2 degrees in the last hour. Which of the following represents the net change in temperature over the 6 hours? Okay, well, the first thing I notice very quickly is that dropping by 3 degrees means -3. And then if you do that for the total of 5 of each of the 5 first hours, well, that's going to mean that you have negative a negative drop, a -3, 5 times. Well, that's a negative value. Well, let's look at C and D. C and D do not represent a -3. That's not a drop, that's an increase. So they are not options. So they're out, and that leaves us A and B. Well, they both have -3 times each of the 5 hours. I agree with that. And then when it says rose by 2 in the last hour, well, that would be +2. Well, I agree with that. The only difference in A and B is the result. Okay, so let's put that in the calculator and see what comes out. But also notice they use parentheses. That's not normal notation, but it is acceptable notation. There's no reason not to do what they've done. So let's type it in exactly the way they've done this. Okay, +2. Notice what I've done. Parentheses -3, then parentheses 5, plus the 2, exactly what they did. Push enter. And that is a drop of -13 degrees. So option A is correct. Okay, now let's go to number 6. All right. What is the value of 3 1/4 minus 5 2/7? Okay, now notice that you got a smaller number that is subtracted. You're subtracting by a larger number. So you're taking a larger amount from a smaller amount. Well, that means our answer has to be negative. Okay, because if you say 3 minus 5, well, that's -2-ish, around 2. So obviously we can eliminate A and D. Well, let's put our expression in and see what happens. So second fraction, that gives us our mixed number, and that's 3, arrow over 1, arrow down 4, arrow over, then minus second fraction, that's 5, arrow over, 2, arrow down 7. Okay, I'm arrowing all the way over so I can make sure that I actually entered it correctly. If you've watched my other videos, I don't always have to fix it when I do it incorrectly. Okay, let's push enter. Ooh, well, that's not a mixed number. Well, not a big deal. Don't panic. Don't think it's wrong. Just turn it into a mixed number and then see what happens. Okay, so what do? I do second, and I need to push the scientific notation button right there. I know it's hard to read. Don't worry about it. That's what you're telling it, the calculator, go from a fraction to a mixed number. So let's push enter, and it does. So option B is what we need. Let's look at number 7. A store has 2 rolls of the same ribbon. One roll has 10 and 7/8 yards of ribbon, and the other roll has 12 and 1/4 yards of ribbon. Okay, so what am I probably going to have to do? I'm saying they're asking, you probably got to add those together. But let's see what happens. The store sells 4 pieces of ribbon, each sold. Each piece sold is 4 and 3/8 yards long. So what am I doing here? I'm going to have to add those 2 rolls together so I know the total. And then I will subtract. I'm sorry. Well, I am subtracting. But before I subtract, I need to multiply 4 times 4 and 3/8. So I take all the ribbon that's in the store and subtract out all the amounts of ribbon that have been sold. Okay, so let's put this in the calculator. Now, what you're going to do is what I have circled. Those items, probably ought to put those in parentheses, okay? So I'm going to arrow down just so you see that, all right? So parentheses, second fraction, 10, arrow over, 7, arrow down, 8, arrow over. Now I'm adding these together. So I push add, then second fraction, 12, arrow over, and I need 1, arrow down, 4, arrow over, close my parentheses. Now I'm subtracting another set of parentheses. So parentheses, 4 times, then second fraction, and then 4, arrow over. Notice what happens when I arrow over. It really pushes me where I need to be so I can see what I'm doing. So then 3, arrow down, 8, arrow completely over so you can put in your parentheses. Now, you may have been able to enter this differently, but I use parentheses to be safe. Order of operations does come into play, and the calculator cannot read your mind. It only does what you enter. So sometimes using parentheses in combination with other safe things will help. For example, I used my mixed number instead of using division for my fractions. It sets up a solid order of operations. So let's push enter. Well, that's not an option. However, remember what we do. We use the second, and that it's the button we push is actually the scientific notation, but above it is the toggle option. So what we've done is say, I want to go, because that'll get me back and forth, okay? So I'm going to my mixed number, push enter. There we go. Option B is the correct selection. Right. And thank you so much for watching and subscribing and liking and sharing. Everyone who's done that, you guys are amazing. And happy testing, everybody.